This talk's going to be a little disorganized, but hopefully in a useful way, because I changed a lot of it based on things I've been thinking about on the issue of planetary intelligence. So thank you for having me here. So I'm just going to start by talking a little bit about a project that Steve and Dick got me involved in. He called me up, said, we're having this conference, a NASA conference, and I want you to speak about what it's like to be an alien. And I said, this is even too weird for me, and I'm, a philosopher. I do talk about strange things. But he convinced me to go ahead and give the talk. And I thought about it, and I didn't realize that Stephen himself was actually very interested in this issue too. I argued that the greatest alien intelligences would actually be superintelligences, because I had been thinking about work in computer science and philosophy on this topic. And I looked at two things. I looked at the issue of machine consciousness and also the issue of how to understand superintelligent minds. And so I'm going to talk about that today. And I'm going to try to tie it in to the idea of a planetary computronium, which I think is fun in light of the kind of work that people like Sarah have been doing. So superintelligent AI, for those of you who haven't thought about it, is artificial intelligence that is by definition smarter than humans in every way possible. Social reasoning, mathematical theorizing, every domain. And of course, this is a hypothetical intelligence. We have not even got anywhere close to this right now. So let me just say a little bit about what I call the post-biological cosmos approach. For those of you who know Paul's work, you're probably familiar with it already, because I believe Paul's discussed it in his book, The Eerie Silence, and probably elsewhere as well. But as Stephen puts it, once any society that creates the technology that could put them in touch with the cosmos, they are only a few hundred years away from changing their own paradigm from biology to synthetic intelligence. So I think this kind of view is familiar to those who do astrobiology. And it's buttressed by observations about the age of the universe and that Earthlings are galactic babies and whatnot. Of course, that means then that the wisest aliens won't look like Yoda. They may look like this, or they could look like the biological creatures that created them. And here on Earth, we see Hiroshi Ishigaru's android modeled after his daughter. So that's food for thought. Why would this be the case? Well, computation is very efficient. So there are advantages to post-biological intelligence, tremendous computational power. You could have a computronium the size of a planet or even larger. There are not the physical limitations of the skull. You could, through enhancement, reach superintelligence quite quicker than just mere neural enhancements. Reboots and system upgrades are possible. Many believe that this would be the route to a sort of immortality. You could upload, perhaps, to survive death. It's easier to survive space travel, and of course a global catastrophe may make an alien world inhospitable to biological life. Okay, now all this being said, I want to move back to the issue of planetary intelligence and distinguish it from this workshop. What I've seen so far are very different senses of planetary intelligence that have been discussed informally and in the talk. So I just want to pull them apart and begin to theorize a little bit. So first off, we see from today's presentations this idea of planetary intelligence, and also Dave's wonderful talk yesterday. So, this is the idea of a state of a planet being determined by human activity, right? And then Sarah's talk, we learned about life as a planetary scale network, which is a kind of intelligence, and it looks like maybe Paul's talking about that in the chapter of his new book as well. Now, in keeping with a respect for broadening the range of cognitive systems, I've been going to a lot of conferences on kinds of cognizers, excuse me. I'm seeing an increasing interest in alternate types of cognitive systems, non-paradigmatic ones like slime molds, plants, and so on. So it does occur to me that you could view, in this second sense here, a planet as a kind of cognitive system, right? But in the first sense, I don't really see that as a cognizer. I don't see a planet as a cognizer in the first sense. In the second sense, I do. But notice, though, even in this second sense here, not all cognitive systems are minded. The slime mold, we don't refer to that as something that has a mind or is a self. Persons are the kinds of things which we think are minded. It remains to be seen whether there will be a planetary intelligence in a third sense, which I identify here, which is a planet as a sentient cognitive system or a mind. Now, I don't have any problem with using the expression mind in a weaker sense, or talking about even the planet as a cognitive system in the first sense. But all I'm suggesting is it's useful to keep these different senses in mind. Why? Well, one thing, and here I'm being very speculative, forgive me, but network theory brings resources to the table when it comes to the level of life and to the level of the brain, right? So if we can separate out a taxonomy of different kinds of senses in which we're talking about planetary cognition, we might be able to use the resources of network theory, among other things, to distinguish different kinds of information processing or organizational principles. That would be really cool. Now, I want to say a little bit more about 2 and 3. So I distinguished life as a planetary scale network from a planet as a mind or sentient cognizer. Oops, sorry, I just lost my slide. However, there we are. And so regarding these 2 categories, the latter 2 categories, one thing that could be of relevance here is an idea that you see among transhumanists such as Ray Kurzweil and also interesting physicists like Frank Tipler. The idea is a planet as a computronium. That is, a massive supercomputer that utilizes all of the matter or a lot of the matter within a planet for its computations. But why stop there? That's a kind of superintelligence. So it's very relevant to planetary intelligence and today's discussion. But, this is just from an astrobiology textbook by Seth Shostak and Bennett, I believe. And, this is the coral model of galactic expansion or colonization, right? And I'm not saying I agree with this. I think it's pretty anthropocentric. But, I mean, the idea here is, if you have a planetary superintelligence, it may not stop there, right? I mean, wouldn't it be, an interstellar intelligence? So let's expand the idea of a computronium, right? We don't just want to talk about planetary intelligence. We might want to talk about, interstellar intelligence, right? I mean, there may be entire regions, or heck, we could even talk about the whole universe, or why not the multiverse? Okay, so this gets really fun. Don't think about computational intractability and issues that we might have in thinking about these things, but it does get fun to think about. Okay, well, so today's task, I'm going to try to say a little bit more about this idea of a galactic computronium, but I'm going to pose 2 questions. So the first question is, would a superintelligence of any stripe, whether it be an embodied being like an android on Earth or a planet, be the sort of thing that has conscious experience? Would it feel a certain way to be it? And why would it matter? Secondly, how might a superintelligence think? Now, this is a vexed question because in the superintelligence community, people at the Machine Intelligence Research Institute and over at Oxford, they say we just don't know what the shape of a superintelligence would be. It will be wholly alien. So I think we shouldn't be so skeptical right from the get-go. Okay, so this being said, you know, please don't take me as suggesting that there really is life out there, that all of those exoplanets are not just habitable, but actually inhabited. I am actually on the fence about these issues, and if I had more time, I would be telling you about the Fermi paradox, and I would be talking about the great filter. However, I want to talk more about this idea of superintelligence and planetary intelligence today, so I'm going to move on, but if you are interested in these kinds of things, I gave a talk on this at the Idea Festival that was televised on PBS, and you can find that at my website. Okay, so I'm going to skip some slides then, sorry, and get to these questions. The hard problem of consciousness. I think a lot of people understand the problem in this group, but I'll just mention quickly that this is a problem about the nature of experience. So this is a problem that asks, why doesn't all of our information processing happen in the dark? Why do we need to have experience? So this is a question about human consciousness. The problem of artificial consciousness is a bit different but related. This is asking, could a silicon-based computer, or a computer made of some other form of microchip, graphene, carbon nanotubes, I mean, there are all kinds of things under development right now, could it have experience? And why would it not just be a sophisticated information processing system without any experience whatsoever? Well, in my work with DARPA, which I really can't talk about actually, in my book, I forgot this is being filmed, in my book, The Future of the Mind, I offer tests for machine consciousness. The book's coming out soon. Happy to pass around the manuscript. But I'm not going to talk about the tests for machine consciousness today. Today, I'm just going to sort of lay out some of the issues. So why does the issue of machine consciousness matter? Well, if a superintelligence, whether it be a planet or an individual that walks the face of the Earth, if it can't have inner experience, then I believe advocates of the post-biological approach in astrobiology should actually be concerned about this. So if machines can't be conscious, we should be concerned. Why? Well, a technological singularity that led to post-biological existence, whether it be on Earth or elsewhere, could lead to far greater intelligence, but fewer conscious beings in the universe. Right? So all of this wonderful intelligence wouldn't be realized by sentient systems. It wouldn't feel like anything. So if the universe becomes post-biological in this Ray Kurzweil fashion, he's envisioning the universe lighting up with conscious experience. And that sounds glorious. But if machines can't be conscious, it's not glorious. It actually would be the end of conscious life. Okay. So a human merger along similar lines with AI, so Elon Musk has been advocating this as a solution to technological unemployment and to keep up with superintelligence. I replace parts of my brain with microchips that underwrite conscious experience. I am in effect becoming a zombie, as philosophers in the philosophical sense. I would become basically an artificial intelligence that didn't have conscious experience anymore upon total replacement of parts of my brain with brain chips. So the idea of merging with AI, that wouldn't be a means for you to enhance your lives. Okay, further, I think the issue is important in sketching the space of intelligent systems. So understanding, for instance, planets as a cognitive system versus one that is not just a cognitive system, but which is minded. Sentient beings are the kind of things that would be minded. And also implications for the control problem of artificial intelligence, which I'll talk about shortly. And then there are ethical issues about how you should treat sentient or conscious beings. So let's now turn to considerations that suggest that superintelligence and artificial intelligence more generally may not be conscious, because I'm actually somewhat skeptical. I argue for a sort of middle-of-the-road approach in my book, so I'm going to lay out some reasons for skepticism. I have what's called a wait-and-see approach, and at the end I'll tell you a few reasons to also think it may be developed. Okay, so here's one consideration. So it may be more efficient for a superintelligence or even an artificial general intelligence that stops short of being a superintelligent to eliminate consciousness altogether, okay? So think about how consciousness works in the human case. In the human case, consciousness is reserved for times in which you're learning something novel, you're engaging in processing that requires slow, deliberative focus. So think about when you were learning to drive, how slow and deliberative you were as you were driving, and then think of those days when you're driving home and you're zooming home and you're, well, I hope you're not like me, like eating a bagel and doing texts and whatnot, but you're like, God, I don't even remember going over that bridge. Well, that's because it's become routinized, right? I mean, a lot of what we do becomes routinized, and when it is, it becomes non-conscious activity. That's how consciousness works in at least biological systems. But an AI that has the capacity to, you know, have the internet at its immediate disposal, or which is a galactic or even planetary-sized computronium, why would it need a mental faculty designed for slow, deliberative processing? Right? I mean, wouldn't it already have mastered everything already? So why wouldn't everything be just routinized and not actually under the attentional spotlight? In short, a superintelligence or even an artificial general intelligence that's not fully superintelligent may not need consciousness anymore. So for all we know, the smartest AIs may not be conscious. This is something I was just thinking about this morning, and you know, I think there might be certain restrictions on conscious computroniums. So think about a computronium that extends from here to Alpha Centauri. Its mental processing would have to be extraordinarily slow if it was conscious. If there was a space where things had to come together and be unified. Like consciousness is associated with a unified field. You can tell that right now by introspecting. Things appear to all come together under a sort of spotlight of attention. Well, how is it that a computronium that extends from here to Alpha Centauri could do that when a signal is an 8-year round trip to and from Alpha Centauri back to Earth? So there would be an issue with timing of conscious experience. When it comes to the timing of conscious experience, things work at the millisecond level. I mean, there are already studies, very important studies, by Benjamin Libet and others talking about important distinctions involving 100 milliseconds or 200 milliseconds. So even to think about the time it would take for signals to go to and from the moon, which is a few seconds, I believe, that computronium may not even have conscious abilities. We need to think about that. Now, would that present an, in principle, architectural constraint on planetary intelligence? I wonder. I mean, I think the issue's worth considering. You could think of systems on Earth which are disunified systems which have pockets of consciousness. Maybe a planetary intelligence would need to be like that to be efficient and operate in real time. Or maybe it wouldn't operate in real time and it would have very slow unified experience. But these are architectural differences at the level of information processing theories right now that we could think about. So I think this is fascinating. I mean, they're on Earth right now. There's a case of twins that are conjoined at the head. They're conjoined twins who have a novel anatomical structure of qualia or consciousness transfer. They have a thalamic bridge. How many people have heard of this case? It's absolutely fascinating. I just wrote a piece for Slate on it, just a little fun piece, but you know, when one twin eats peanut butter, the other one immediately tastes it. So maybe a superintelligence would need to do something like that to share conscious activity because of issues with respect to timing in the brain. But maybe a system doesn't need to be conscious at all. I mean, this goes back to my skepticism about whether an advanced intelligence would even need to be conscious. Okay, well, there are also practical considerations militating against conscious superintelligences or artificial general intelligences when they're at a smaller scale, developed by Earthlings, for instance. So, you know, on Earth right now, I mean, one consideration that I talk about in my book is that the properties that give rise to sophisticated information processing systems and which artificial intelligence developers care about, they may not be the very same properties that yield consciousness, right? I mean, there's work on the hot zone right now in neuroscience, which is absolutely fascinating, that suggests that sensory processing is the neural correlate of consciousness. And here you could ask, why would an AI even need to have a hot zone, or would it even need to be at the level of resolution such that it would actually have conscious experience? I mean, all it needs to do is engage in clever information processing. So why wouldn't an AI company just cheap out on consciousness, right? Why does it need to be conscious? Okay, finally, PR nightmares. So one thing I'm experiencing right now as I speak at AI conferences is, you know, a real surge of concern about robo-rights. Very valid concern. I mean, why should humans build a slave class? I mean, clearly, if it turns out that AI is conscious, those systems can't be marketed or deployed if there are ethical constraints on their use. So these should be issues that AI companies care about. So consciousness might actually be deliberately engineered out of systems that are designed to serve us. Some people like to talk about dialing it out of a system. I find that ethically pretty scary. You know, there are a lot of ethical questions there. On the other hand, I have a wait-and-see approach about machine consciousness. I wouldn't settle anything at the armchair at all. So I do want to emphasize some reasons why Earthlings may seek to develop conscious machines in a deliberate engineering effort. So maybe the public will demand conscious AI companions. So think about the film Her, in which Theodore had a relationship with Samantha, a conscious personal assistant. I mean, maybe people will want conscious systems in their relationships. I don't doubt that there will be some people who have relationships with AIs. So that might be a reason why AI companies deliberately engineer it into certain systems, and hopefully there are also ethical constraints on their use. Another reason, which I think is absolutely fascinating, is the possibility that conscious systems will be safer systems. And I'll talk about that when I get to the control problem. Neural prosthetics, I think that's a biggie. So suppose you need a brain chip because your hippocampus has been ruined. There's already clinical trials on artificial hippocampi, and the hippocampus is very well understood computationally. It's extremely cool to think about. So what if you put a neural prosthetic in your hippocampus? Okay, well, that is probably not part of the brain that is giving rise to conscious experience, but what if your next replacement is part of your claustrum or your thalamus, which in a lot of theories of the neural basis of consciousness, we're getting closer to areas that are a little bit more risky. If you replace them with neural prosthetics, you might lose conscious experience. Okay? So as medicine develops neural prosthetics, it may be that it actually needs to perfect chips that give rise to conscious experience. So that might be a reason why humans on Earth and people having their own, creatures having their own singularities on other planets may actually care to develop conscious chips. Okay, so there are also other issues like uploading and whatnot, but I think what I want to do here is I just want to summarize and say that it's not at all clear whether machines would be conscious. I think it would take a deliberate engineering effort, and I'm also getting a sense from these conversations we've been having on planetary superintelligence that the considerations there for consciousness, the factors that may give rise to consciousness, could be entirely different altogether than the kinds of things that I've surveyed in the context of AI projects on Earth. So I think the computronium issues with timing, architectural efficiency considerations, these kinds of things are important to think about in the context of conscious computroniums. Okay, so I'm not going to get to breakthrough starshot, but some of us are talking about sentient AIs in the context of space projects, in the context of chips on starshot. How would superintelligences think? That's what I want to turn to now. So I've stressed that intelligence and consciousness come apart, quite possibly. So there's a lot of interesting work on superintelligence right now. I am particularly impressed by a book by Nick Bostrom that's been widely discussed at this point. He distinguishes between 3 different kinds of superintelligence. So he talks about speed superintelligence, and you can write PhD theses in the course of an hour. Wouldn't that be great? But they're not necessarily better theses than what we could do, at least. And then collective superintelligence, which is sort of like the Star Trek Borg. Each unit isn't highly intelligent, but collectively they constitute an intelligent system that is qualitatively different than us. And then he talks about just a quality superintelligence that is smarter than us in every way possible. Okay, so that's about all that Bostrom wants to say about the computational structure of a superintelligence, because he believes that they're inscrutable and wholly alien, to use his expressions, or they will be. So, if you believe that, you don't say very much about their structure. He does, though, talk about an orthogonality thesis. He says intelligence and final goals are orthogonal. More or less any level intelligence could be combined with more or less any final goal. And of course, this is a reason why issues of control become important. So I'll say quickly what the control problem is, because I've kind of mentioned it in passing a few times. Well, the control problem arises for both conscious and non-conscious superintelligences, and I think it even arises for powerful artificial general intelligences that are not superintelligent. Military leaders worry, could consciousness make things even worse? Could it make AI more volatile? All right. Well, look, let me just say, I skipped ahead, pardon me. The control problem, to be clear, is a problem of how to control superintelligent AI. People don't talk about how consciousness plays a role in this, whether it does or does not play a role in the control problem. But people worry, if you have a conscious system, would it somehow be harder to control? So think of a teenager in the throes of hormones. Would it be like that? Oh God, we're dead. We're dead. Right. But I've told them, we can't assume that consciousness would do that. All right? Because think about the case of animal liberation. For those of us that care about the ethical treatment of non-human animals, why do we care? It's because we believe it feels like something to be the animal. We extrapolate based on the presence of our own conscious experience to the presence of conscious experience in them. So it is our own consciousness which leads us to protect inferior beings. So my stance on this is that we need to entertain the possibility that a conscious system will actually make things better for artificial intelligence safety. So what would be important then, and I won't have time to go into this today, is testing for machine consciousness and determining in each architectural system at the R&D stage, if it's found to be conscious, what the impact is on the other parameters of the system. Okay, so this being said, I'm going to quickly just return back to the planet. All right, what I want to do now, how much time do I have? Or did I just lose?
We have about 10 minutes.
Oh, good. Okay, so.
Questions, though. So.
Oh, okay, so, all right. I want to get back to planets, but let me just say something. In my thinking about the structure of superintelligences, I think there's a class of superintelligences which we can say more about than Bostrom does. So Bostrom just throws his hands up, says, they're super intelligent, so we're not. But there are resources in cognitive science which you could bring to bear on understanding superintelligent systems, especially ones that are modeled after biological systems. So notice how deep learning systems, for instance, are roughly modeled after the multi-layered neural network structure of the human brain. Okay? And these are the most successful systems right now on Earth. So if a superintelligence is like that, then the more computational principles from cognitive science that we have used in the past to describe the human brain, the better, let me rephrase that. We could take principles from cognitive science that we have used in the context of explaining the human brain and apply them to these kinds of superintelligent systems, the ones that are biologically inspired. So this class of systems I call BISAs, biologically inspired superintelligent aliens, and they're superintelligences that are based on reverse engineering the brain. So I suspect this is the most likely development of superintelligence on Earth. And I think the interesting question here is, would a computronium be a biologically inspired superintelligence? Would it have the same sort of structure as a biological brain? And here I'm using brain to not just refer to brains, earthly brains, but alien minds, if you will. And so I'm wondering if we could use principles in cognitive science to understand computronium level intelligence. Now, what principles in cognitive science, you might ask? Well, here are some that I've been using. So when I was thinking of superintelligence, I was not thinking at the planet's level. I was just thinking of, embodied creatures. But I think that BISAs, these biologically inspired superintelligences, would obviously be descended from creatures that had motivations like avoid injury and predators, reproduce, cooperate, and so on. So they would have final goals involving their own survival and possibly reproduction. So you might expect simulations. And BISAs would be based on brains evolved to deal with biological constraints like slow processing speed and the spatial limitations of embodied life. So the BISAs may end up having upgraded versions of cognitive capacities that embodied beings have. And you could look to the ones in particular that were incredibly useful to keep. So an example would be combinatorial mental representations. There are other examples too. And I think this one is really interesting. So BISAs might have one or more global workspaces. So when you search for a fact or concentrate on something, your brain gates that sensory content or cognitive content, gives it access to a global workspace where the information is globally broadcast to the brain for special attention and more concentrated processing. So there's some really interesting work in connectomics on this, on hubs, network theory, by people like Olaf Sporns and others. And it is all predicated on the idea that there needs to be a central executive or a place where it all comes together. Now, going back to what I said earlier about the computronium, because of these possible spatial limitations in signaling, it may be that a computronium just can't have this kind of structure. So it's a point of contrast. There may be very distinct kinds of superintelligences. There are other explanatory methods in cognitive science you can use to understand superintelligent brains, or minds, if you will. Functional decomposition is a common method of decomposing a cognitive or perceptual function into causally organized parts. Viewpoint invariant representations are quite common in cognitive systems, and you could also wonder if superintelligences needed those. Well, anyway, this is all to say that I think there's a lot of work that could still be done. We have, of course, to remain humble and realize that a superintelligence has recursive self-improving algorithms and can change its architecture at any time. We're not very smart. A superintelligence is, by definition, far smarter than us. But because of the import of the control problem, I think that we still, nevertheless, should humbly try to use our theoretical resources to understand the computational structure of these systems. You never know. Okay, so in my own work on the computational format of thought, I've thought about some of these issues. So there's debates about whether the format of thought would be shared again across radically different types of cognitive systems. Does there need to be a sort of common code, cognitively speaking? Is there a lingua franca of thought, if you will? And these are really intriguing debates right now in the context of the scope and limits of deep learning systems. Okay, so now I'm going to sum up. Well, the talk changed a lot, as I wrote it this morning. But to go back to the NASA invitation to talk about what it's like to be an alien, I did offer a provisional answer, which is I can say something about what I think will be going on with the most intelligent systems. And that's not to say that all aliens or most life would be artificial. That's not my view at all. I mean, most life would be microbial. But the most intelligent systems, they would likely be superintelligent artificial intelligences. And I think we can begin to pull apart types of superintelligences, different planetary types of intelligence, as well as these biologically inspired superintelligent systems, and begin to use theoretical resources ranging from work on multimodal organization, in the brain, like how it is that we combine material from different sensory domains, to network theory, and issues involving the scope and limits of deep learning, as well as resources on superintelligence that are being worked on right now by computer scientists. Thank you.
Thanks so much. That was great. So we do have time for a couple questions. So I'm going to give it.
Very quick one. What would it take for a superintelligent AI that is not conscious to convince me it is not conscious? So like a sort of inverse Turing test. How would it convince me? And if it's not falsifiable, does it mean anything?
These are such difficult questions. I mean, so I have this little piece in Scientific American with Edwin Turner, and he and I were thinking that you could at least box in certain AI systems and have a sufficient condition on detecting consciousness. Wow. But that doesn't answer that issue. And if it's not a system that is boxed in, if it has contact with information in the world, if it knows about human minds, then even if it's not conscious, it can quickly infer the import of acting conscious or not acting conscious. Right. So I'm not sure you could really trust right. And so I think that's why you have to be very careful with the scope and limits of those tests.
Hi, I was just wondering, can you really actually have superintelligence or consciousness or intelligence period if you can't change the world around you, if you don't have some kind of causal influence on other matter that's not your own information, if that makes sense?
So, yes, it makes sense, and a superintelligence should be able to act causally. I'm taking it, it's not just an abstract program, but something which is a concrete implementation of the program.
He's talking about embodiment.
Yeah, well, implementation is embodied. I mean, it's a physical thing, and it would, even if it didn't have, a human form or be ambulatory, it could still have sensory experience. But it may decide to download into an Android body or whatnot.
It's a quick question. Under your thinking, would your superintelligence have a sense of humor?
Well, it's supposed to be better than us in every way possible, so it should be really funny. It should be able to go on Saturday Night Live and crack us up. Best Trump imitation ever.
But, okay. All right. Thank you so much. That was great.
Thank you.